The skies above the French coastline near Dieppe were thick with cloud cover on that spring day in mid-April of 1943. Major Donald Blakesley sat in the cramped cockpit of his Republic P-47 Thunderbolt, maintaining altitude at 20,000 feet, his leather-gloved hand maintaining a firm grip on the control column. The frustration of recent weeks spent dealing with mechanical breakdowns and endless training exercises was about to evaporate in the span of a few violent seconds. Below him, emerging from the layers of white vapour, came the unmistakable outline of a German fighter aircraft. The moment that pilots of the 4th Fighter Group had been waiting for had finally arrived. The transition to these massive American fighters hadn't been easy. British pilots had taken one look at the bulky machines and dismissed them with characteristic wit, calling them 7-ton milk bottles, a nickname that stung because it contained more than a grain of truth. The Thunderbolt was enormous compared to anything else in the sky. But size, as the Germans were about to learn, brought advantages that transcended the traditional measurements of fighter aircraft performance. Through the gun sight mounted before his eyes, Blakesley tracked the movements of the enemy aircraft with growing anticipation. The Focke-Wulf 190 belonged to Jagdgeschwader 26 Schlageter, one of the Luftwaffe's most experienced fighter wings, though the German pilot had no way of knowing he was about to become a footnote in aviation history. When the range closed to 300 yards, Blakesley's thumb found the firing button. What happened next was something that no German pilot had experienced before in aerial combat. 8 Browning A&M 250 caliber machine guns, 4 mounted in each wing of the Thunderbolt, erupted simultaneously in a cacophony of mechanical violence. Each weapon was cycling at 800 rounds every 60 seconds, creating a theoretical combined rate of fire that exceeded 6,400 rounds per minute. The mathematics were straightforward, but the reality was overwhelming. A concentrated stream of armour-piercing incendiary ammunition, each projectile half an inch in diameter and weighing nearly 2 ounces, converged on the German fighter in a pattern of destruction that defied the opponent's ability to evade or survive. The Focke-Wulf 190, which represented the pride of German fighter engineering with its pair of 20mm MG-151 cannon and two 7.92mm MG-17 machine guns, simply came apart under the onslaught. The structural integrity of the airframe couldn't withstand the concentrated firepower. Within seconds, pieces of the aircraft were tumbling through the sky, trailing smoke and flame. This single moment marked the first aerial victory for the P-47 Thunderbolt in combat, establishing the beginning of a fundamental shift in how air combat would be conducted for the remainder of the war. The Americans had constructed more than just another fighter plane. They had created a flying weapons platform that would force a complete re-evaluation of what constituted effective firepower in aerial warfare, replacing European concepts of precision and efficiency with an American philosophy built on overwhelming abundance delivered through industrial mass production. The path to that first victory had been paved with months of difficulty and adaptation. When the 4th Fighter Group had flown its initial operational sortie on the 10th of March in 1943, the mission had been nothing more than a fighter sweep over occupied France, intended to familiarize pilots with combat operations. Radio equipment failures had plagued that first attempt, forcing the entire formation to return to base without engaging the enemy. British radio sets had to be installed in the American fighters before operations could continue effectively. Throughout the early months of 1943, the pilots of the 4th Fighter Group, who had previously served in the Royal Air Force as the famous Eagle squadrons before transferring to American service, struggled mightily with the transition from the nimble, responsive Supermarine Spitfire to the massive, powerful Thunderbolt. The weight difference alone was staggering. An empty P-47 Thunderbolt tipped the scales at 12,731 pounds. When fully loaded with fuel, ammunition and pilot, that figure climbed to 17,500 pounds. For comparison, the Messerschmitt Bf-109G, which served as Germany's primary single-engine fighter, weighed less than half that amount. The disparity seemed to violate every principle that European fighter designers held sacred. Meanwhile, at Republic Aviation's massive manufacturing facility located in Farmingdale, New York, these giants were rolling off assembly lines at rates that would have seemed impossible just a few years earlier. By the time April of 1943 arrived, Republic was completing one finished P-47 Thunderbolt every 4 hours of every working day, and production rates were accelerating with each passing month as manufacturing processes were refined and optimized. Alexander Kartveli, the chief designer born in the nation of Georgia, had approached the entire problem of fighter aircraft design with a philosophy that seemed absurd, even insane, to engineers trained in European traditions. His thinking could be summarized simply as maximum firepower delivered through maximum available power. Where German designers spent countless hours agonizing over weight reductions measured in individual grams, shaving ounces from every component to achieve optimal performance, Kartveli simply added more guns, more ammunition, and more armor plating. If the engine was powerful enough and the airframe strong enough, weight was merely another engineering challenge to be solved through brute force rather than an insurmountable obstacle requiring endless compromise. Colonel Hubert Zemke, who commanded the 56th Fighter Group, understood this American approach to fighter design intuitively. His unit had arrived in England during January of 1943, and by April was flying regular combat missions against German forces. The 56th would earn the distinction of being the only 8th Air Force fighter group to fly P-47 Thunderbolts exclusively from beginning to end of the European War, never transitioning to the longer-range P-51 Mustang that other groups would eventually adopt. By war's end, the 56th Fighter Group would claim 674 confirmed aerial victories, a testament to both the aircraft and the men who flew it. The pure mathematics underlying the P-47's firepower capability were remarkably straightforward, though the practical implications were revolutionary. The early production models, designated P-47C and P-47D, carried 350 rounds of ammunition for each of the 8 machine guns, totaling 2,800 rounds available for combat. The 8 weapons were arranged in 2 groups of 4, 1 group in each wing, and the aircraft's armament system was designed to create a convergence zone at approximately 250 yards from the nose of the aircraft. At this specific distance, all 8 streams of bullets intersected in the same area of airspace, creating a concentration of firepower that exceeded anything previously witnessed in combat between single-engine fighter aircraft. A pilot holding down the firing button for just 1 second would send 107 half-inch projectiles downrange, each one traveling at 2,840 feet per second, with enough kinetic energy to penetrate armor plate or tear through aluminum airframes with equal ease. Intelligence officers working for the Luftwaffe initially refused to believe the reports filtering back from pilots who had encountered the new American fighters. 8 heavy machine guns mounted on a single-engine fighter seemed technically impossible according to their understanding of aircraft design principles. German fighter doctrine, developed over years of combat experience, emphasized efficiency above all other considerations. The goal was to mount the minimum armament necessary to destroy enemy aircraft while conserving every possible ounce of weight to maximize performance in speed, climb rate, and maneuverability. The Focke-Wulf 190A5, which served as the primary Luftwaffe fighter defending occupied Western Europe during the spring of 1943, carried 2 7.92mm MG-17 machine guns with 1,000 rounds of ammunition each, along with 2 20mm MG-151-20 cannon mounted in the wing roots with 250 rounds per weapon. While the 20mm explosive shells were individually far more destructive than 50 caliber bullets, capable of blowing large holes in aircraft structures with a single hit, the limited ammunition supply of only 500 total cannon rounds demanded precise marksmanship from pilots. German aviators had developed attack techniques specifically designed around ammunition conservation, emphasizing short, carefully aimed bursts fired at close range where accuracy was highest and the probability of wasting precious rounds was minimized. This tactical philosophy had served German pilots well in combat against British Spitfires and Hurricanes, which typically carried 8 rifle-caliber machine guns or various combinations of machine guns and cannon with ammunition loads that required similar conservation. Following Blakesley's historic first victory on the 15th of April, encounters between P-47 formations and German fighter units increased in frequency with each passing day. On April 17th, Thunderbolts of the 4th Fighter Group flew their first bomber escort mission, though limitations with the early drop tank configurations forced them to turn back before reaching the target area, leaving the bombers unprotected for the final leg of their mission. The psychological impact on German pilots who survived encounters with the heavily armed American fighters was immediate and profound. The visual effect created by 8 guns firing simultaneously was unlike anything previously encountered in the air war over Europe. The P-47's standard ammunition loading sequence called for 4 armor-piercing incendiary rounds, followed by 1 tracer round in a repeating pattern. This meant that every 5th round glowed brightly in flight, creating the visual appearance of a continuous, unbroken beam of light rather than individual projectiles travelling through the air. By May of 1943, the Luftwaffe's research and testing facility at Rechlin had obtained captured P-47 components for detailed examination. German engineers discovered that the Browning ANM-2 machine gun, despite being based on a design that dated back to 1933, had been refined through years of mass production to achieve unprecedented levels of mechanical reliability. Parts were truly interchangeable in ways that German manufacturing couldn't match. Any component removed from any gun would fit perfectly into any other gun of the same type, a level of standardization and precision manufacturing that German industry, despite its reputation for quality, simply couldn't achieve at scale. The ammunition feed system employed disintegrating link belts that ejected cleanly from the aircraft during firing, eliminating the weight and complexity of retaining spent links. German fighters, by contrast, used either drum magazines limited to between 60 and 200 rounds depending on the weapon, or belt-fed systems that retained the metal links, adding dead weight that increased with every round fired. The reliability of the American feeding system was such that pilots could, if tactically necessary, fire their entire ammunition load in one continuous, uninterrupted burst without experiencing stoppages or jams. The scale of American ammunition production capacity stunned German analysts who examined the intelligence reports. By the middle of 1943, the 8th Air Force was routinely flying more than 200 P-47 sorties on any given day of operations. With each aircraft carrying 2,800 rounds and pilots typically expending approximately 60% of their available ammunition during combat missions, this translated to roughly 336,000 rounds being fired daily over occupied Europe. This single-day expenditure exceeded the entire weekly ammunition allocation for all German fighter forces defending France. The Lake City Army Ammunition Plant, located in Missouri, had reached a production capacity of 1,600,000,000 rounds annually by 1943. This single American manufacturing facility outproduced Germany's entire small arms ammunition industry across all calibers and weapon types. The plant operated continuously around the clock with 20,000 workers divided into shifts, maintaining quality control standards that rejected any individual round varying more than 1/10,000th of an inch from established specifications. Every bullet that left the factory had been inspected multiple times to ensure it would function flawlessly when a pilot needed it most. Republic Aviation's production capacity was equally impressive when examined in detail. The Farmingdale manufacturing plant covered 765,000 square feet of factory floor space, with additional P-47 production taking place at a second facility in Evansville, Indiana. Combined output from both plants reached more than 400 completed P-47 Thunderbolts every month by late 1943, while German fighter production of all types combined struggled to exceed 1,000 aircraft monthly across their entire industrial base. German fighter doctrine continued to emphasize lightweight, highly maneuverable aircraft that could outperform opponents in turning combat. The Messerschmitt Bf 109 G6 variant weighed 6,940 pounds when fully loaded for combat. The Focke-Wulf 190A5 reached 9,040 pounds maximum weight. The P-47C model weighed 13,500 pounds loaded, while the improved P-47D reached 14,500 pounds, weights that seemed impossibly heavy by traditional German design standards. Yet the P-47's Pratt & Whitney R2800 double wasp engine, producing 2,000 horsepower in initial versions and 2,300 horsepower in later models, provided power-to-weight ratios that remained competitive with lighter German fighters. The additional weight provided exceptional stability as a gun platform and the ability to absorb tremendous battle damage that would destroy lighter aircraft. The General Electric turbo supercharger system alone weighed 845 pounds, nearly equal to the entire armament weight allowance on German fighters. But this complex system maintained full engine power output at 30,000 feet altitude, heights where the BMW 801 radial engine powering the Focke-Wulf 190 lost significant power above 20,000 feet due to the thinning atmosphere. The shock of facing concentrated P-47 firepower in combat forced immediate changes in Luftwaffe tactical doctrine. Traditional attack methods that had proven successful against earlier Allied fighters became suicidal when American Thunderbolts were present in the battle area. American fighters didn't need optimal firing positions worked out through careful maneuvering. Their sheer volume of fire created kill zones that German fighters simply couldn't survive crossing. Luftwaffe units developed new tactics that attempted to emphasize the Focke-Wulf 190's superior roll rate and turning ability at lower altitudes. But reaching low altitude safely required diving through the P-47's defensive fire envelope, running a gauntlet of concentrated machine gun fire that claimed victims with regularity. American pilots learned quickly to use their altitude advantage combined with overwhelming firepower to force German fighters into tactically unfavorable positions where the Americans' strengths were maximized and the Germans' advantages were negated. The contrast in ammunition philosophy between the two air forces was stark and revealing. German pilots entered every combat engagement with between 60 and 90 seconds of total firing time available before their ammunition was completely exhausted. P-47 pilots possessed 30 to 35 seconds of continuous fire capability, which sounds similar until one considers the dramatically different rates of fire and the psychological impact of abundant supply. This disparity created fundamental tactical differences that influenced every aspect of air combat. German pilots were forced to conserve ammunition carefully, picking shots with care and breaking off attacks when ammunition ran low. American pilots fired liberally, using ammunition as a tactical tool to deny airspace to opponents and to maintain psychological pressure. August 17, 1943, brought the first Schweinfurt-Regensburg mission, a massive daylight bombing raid that demonstrated both the P-47's impressive capabilities and its critical limitations. Within the range where Thunderbolts could provide escort protection, they devastated German interceptor forces attempting to reach the bomber formations. The 56th Fighter Group alone claimed 17 confirmed victories without suffering a single loss in return. But the P-47's limited range meant that bombers flew unescorted deep into German territory, where they were savaged by fighters and anti-aircraft fire. The introduction of 108-gallon and later 150-gallon drop tanks progressively extended the P-47's combat radius. By October of 1943, Thunderbolts could escort bombers to targets located 425 miles from their bases in England. Each extension of range meant that German fighters had to wait longer and fly farther from their bases before they could engage the bombers, reducing their own effective combat time and fuel reserves. The infrastructure supporting P-47 operations reached industrial scales that German military planners found incomprehensible when they examined captured documents and intelligence reports. Each P-47 squadron maintained reserve stockpiles of 500,000 rounds of ammunition at their home bases. Forward airfields scattered across England stockpiled millions of rounds ready for immediate use. Supply ships delivered continuous streams of ammunition from American factories across the Atlantic Ocean, braving submarine attacks to maintain the flow of war materials. A typical P-47 group possessed sufficient ammunition stockpiles for 30 days of maximum intensity operations without receiving any resupply whatsoever. German fighter units, by contrast, operated on 3-day ammunition reserves when supply lines were functioning normally, and often had considerably less when disruptions occurred. American pilots fired their guns liberally during combat, while German pilots carefully counted every precious round. Maintenance supplies showed similar disparity between the two forces. American depot facilities maintained complete stocks of replacement engines, entire gun sets, and all major components needed to rebuild damaged aircraft. Damaged P-47s could be completely rebuilt from spare parts in a matter of days and returned to operational service. German units were forced to cannibalize damaged aircraft for spare parts to keep others flying, progressively reducing their operational strength even when the total number of airframes remained theoretically adequate. October 14, 1943, remembered as Black Thursday, brought the second Schweinfurt raid that marked a crucial turning point in the air war. While P-47s flew escort duties to their maximum range, claiming 21 German fighters destroyed, the bombers faced devastating attacks from fresh German fighter units after the American escorts were forced to turn back due to fuel limitations. German pilot combat reports from this period revealed growing concern and reluctance about engaging P-47 formations directly. The mathematics of the situation were irrefutable and deeply troubling. A German fighter squadron, called a Staffel in Luftwaffe organization, consisting of 12 aircraft, might collectively possess 7,000 rounds of mixed-caliber ammunition. A single American P-47 squadron of 16 aircraft carried 44,800 rounds of heavy machine gun ammunition, with millions more rounds stockpiled in reserve at their bases. The firepower advantage was further amplified by significant differences in training standards and preparation. American P-47 pilots arrived in combat theaters with more than 400 hours of total flight time, including 100 hours dedicated specifically to gunnery training. They had fired thousands of practice rounds at towed targets and ground ranges before ever seeing combat. German pilot training programs by late 1943 averaged only 110 flight hours before pilots were sent to operational units, with perhaps 20 hours devoted to gunnery training. Chronic fuel shortages meant that many German pilots entered combat having fired their aircraft's guns only a handful of times during training. They faced American opponents who had expended more ammunition during peacetime training exercises than German pilots would fire during their entire combat careers. Lieutenant Colonel Francis Gabreski, who would eventually become the highest-scoring P-47 ace in the European theatre with 28 confirmed victories, described the tactical reality with characteristic bluntness. American pilots didn't need to be exceptionally skilled marksmen. They simply needed to position their gun sight on an enemy aircraft and hold the trigger down. The 850 caliber guns did everything else, delivering such overwhelming firepower that precise aim became less critical than maintaining steady tracking. By November of 1943, P-47 groups began placing increased emphasis on ground attack missions after completing bomber escort duties. The 850 caliber guns proved devastatingly effective against locomotives, motor vehicles, and parked aircraft on airfields. Armor-piercing incendiary ammunition could penetrate locomotive boilers and vehicle armor with ease. A single P-47 making one firing pass could completely destroy an entire train in less than 10 seconds of sustained fire. The standard attack profile involved rolling into a 30-degree dive, opening fire at 1,000 yards range, using rudder pedals to walk the stream of bullets across the target area, then pulling out of the dive at 200 yards altitude. During those 10 seconds of firing, a Thunderbolt could deliver between 800 and 1,000 rounds into a target area approximately 1 square mile 100 yards in length, creating an inescapable zone of destruction. German transportation networks faced systematic destruction from these attacks. P-47S destroyed locomotives faster than German industry could manufacture replacements. By December of 1943, German military units actively avoided moving by rail during daylight hours due to the certainty of P-47 interdiction attacks. The P-47's crucial role in supporting the strategic bombing campaign cannot be overstated. While the P-51 Mustang would eventually assume primary responsibility for long-range escort duties deep into German territory, P-47s provided the initial defensive shield that allowed the bomber offensive to continue despite heavy losses sustained during the vulnerable period before long-range escorts became available. By early 1944, improved P-47D variants carried 425 rounds per gun, totaling 3,400 rounds available for each mission. This represented a 21% increase in ammunition capacity without compromising any other aspect of the aircraft's performance. On the 6th of June, 1944, the day of the Normandy invasion, P-47 Thunderbolts flew 2,398 individual sorties in support of the ground forces. They claimed 84 German aircraft destroyed in aerial combat and another 89 destroyed on the ground in strafing attacks. More significantly, they completely paralyzed German ground movement through relentless interdiction of roads and railways. The Luftwaffe managed to fly only 319 sorties over the Normandy battlefield on the invasion day. American forces flew more than 13,000 sorties of all types. German fighters operating over Normandy possessed perhaps 200,000 rounds of ammunition total across all their units. American fighter squadrons carried millions of rounds with unlimited resupply capacity from depots in England. P-47S created free fire zones where anything moving during daylight hours was destroyed without mercy. Vehicle columns attempting to move toward the invasion beaches were reduced to burning wreckage in single strafing passes. The distinctive whistling sound produced by diving P-47s, caused by air flowing through gun ports and engine cooling ducts, became a psychological terror weapon in its own right. By late 1944, German fighter aircraft production actually peaked at an impressive 25,000 units annually, demonstrating that German industry retained significant manufacturing capacity despite years of strategic bombing. But chronic fuel shortages, catastrophic pilot losses, and overwhelming Allied numerical superiority meant that most of these newly manufactured aircraft never flew operationally. Those fighters that did manage to reach combat units faced numerical odds regularly exceeding 10-1 against them. The revolutionary Messerschmitt Me 262 jet fighter provided German pilots with a significant speed advantage over any Allied propeller-driven aircraft, but it didn't provide firepower superiority. Its 430mm Mk108 cannon carried only between 80 and 100 rounds per gun, totaling just 360 rounds maximum. While these large-caliber weapons were devastating against bomber formations, the limited ammunition supply combined with the cannon's relatively low muzzle velocity made them considerably less effective in fighter-versus-fighter combat, where targets were small, maneuverable, and heavily armed. The P-47N variant, specifically introduced for Pacific theater operations against Japan, carried 550 gallons of internal fuel capacity. This single-seat fighter aircraft carried more fuel than German medium bomber aircraft, demonstrating American industrial capability to build machines that defied all conventional limitations and traditional design philosophy. Final production numbers tell the complete story of industrial dominance. Total P-47 production across all variants reached 15,683 aircraft built. Peak monthly production from combined manufacturing plants exceeded 400 completed aircraft. Total Focke-Wulf 190 production across all variants from 1941 through 1945 reached approximately 20,000 units. Focke-Wulf 190 fighter variants specifically numbered approximately 13,000 aircraft. Each P-47 that left American factories was fully equipped with all 8 machine guns and adequate ammunition supplies. German fighters were increasingly delivered with reduced armament due to critical shortages of weapons and ammunition. By 1945, some Focke-Wulf 190 units operated aircraft with only 2 cannon instead of the standard 4 weapons to conserve scarce ammunition supplies. Republic Aviation's manufacturing facilities covered more than 1 million square feet of production floor space. German fighter production operated from frequently bombed facilities, with production dispersed to smaller sites to reduce vulnerability, a strategy that significantly reduced manufacturing efficiency. The Lake City Army Ammunition Plant alone produced 1,600,000,000 rounds of 50 caliber ammunition annually. Combined with output from other major facilities including Frankfurt Arsenal, Des Moines Ordnance Plant and Twin Cities Ordnance Plant, American production exceeded 10 billion rounds of 50 caliber ammunition during the entire war. German ammunition production for all aircraft weapons of all calibers combined totaled approximately 4 billion rounds across the same time period. The Americans produced more rounds of their single heavy machine gun caliber than Germany produced of all aircraft ammunition types together, a disparity that fundamentally shaped the air war's outcome. Quality control standards differed dramatically between American and German production. American ammunition underwent multiple inspection stages with rejection rates of 2 to 3% for rounds failing to meet specifications. German production, increasingly dependent on forced labour and substitute materials as the war progressed, experienced significantly higher malfunction rates that reduced effective firepower even when ammunition was available. The United States Strategic Bombing Survey meticulously documented P-47 achievements throughout the European theatre. 3,916 enemy aircraft destroyed in aerial combat engagements. 3,202 enemy aircraft destroyed on the ground during strafing attacks. 9,000 locomotives completely destroyed. 86,000 railway cars destroyed or damaged beyond repair. 68,000 motor vehicles of all types destroyed. 6,000 armoured fighting vehicles, including tanks and assault guns, destroyed. These statistics represent strategic impact that extended far beyond mere tactical success in individual battles. The systematic destruction of transportation infrastructure by roving P-47 formations significantly reduced Wehrmacht mobility and logistics capabilities throughout occupied Europe. The Luftwaffe's complete inability to counter P-47 ground attacks effectively meant that American air power operated with near-total impunity across vast areas. American pilots who successfully completed 25 mission tours, later extended first to 35 and then to 50 missions, rotated home to the United States to serve as instructors training new pilots, spreading combat experience throughout the training system. German pilots flew continuous combat operations until they were killed, captured, or medically incapacitated. By late 1944, the majority of Luftwaffe pilots were inexperienced novices facing battle-hardened American veterans who knew every trick. The experience gap widened continuously and inexorably. American training programs incorporated lessons learned from combat operations immediately, updating tactics and procedures based on after-action reports. German training programs, severely disrupted by fuel shortages and abbreviated by desperate necessity, produced pilots with wildly varying skill levels who faced standardized American tactics refined through systematic analysis. Beyond raw firepower advantages, P-47s incorporated numerous technologies that significantly enhanced overall combat effectiveness. The exhaust-driven turbo supercharger allowed the Pratt & Whitney engine to maintain full power output at extreme altitudes where German engines gasped for air. The R2800's legendary reliability meant consistent performance with routine maintenance intervals of 400 hours between major overhauls, exceptional longevity for high-performance engines of that era. The K-14 computing gun sight, introduced in late 1944, automatically computed deflection angles using gyroscopic principles. Pilots simply framed the target aircraft in the sight and fired, with the sight calculating lead automatically. German fighters continued using reflector sights that required pilots to manually estimate deflection based on experience and intuition. Electrical gun heating systems prevented weapons from freezing at high altitude. P-47 guns functioned reliably at 40,000 feet in ambient temperatures reaching -60 degrees Fahrenheit. German fighters frequently experienced gun freezing problems above 25,000 feet, particularly with wing-mounted weapons exposed to the slipstream. American material abundance extended comprehensively to maintenance operations. P-47 groups maintained extensive inventories of spare parts, complete replacement engines, entire gun sets, propellers, and every component needed for repairs. Experienced ground crews could completely replace an aircraft's engine overnight, returning it to operational status by morning. Battle damage requiring weeks of careful repair work in German workshops was routinely fixed in days at American bases. German maintenance capabilities became increasingly problematic as the war dragged on. Critical spare parts shortages meant constant cannibalization of damaged aircraft to keep others flying. By late 1944, Luftwaffe serviceability rates dropped below 50%, meaning less than half of available aircraft were actually flyable on any given day. American P-47 groups routinely maintained serviceability rates of 85% or higher. American crew chiefs were trained specialists who had received extensive technical education before being assigned to operational units. German ground crews, depleted by conscription that pulled experienced mechanics into combat roles, increasingly consisted of impressed foreign workers and teenage members from youth organizations who possessed minimal training and less motivation. P-47S burned 100/130 grade aviation fuel, the highest octane rating available, allowing engines to run at higher manifold pressures and increased power output without detonation. German synthetic fuel produced from coal through complex industrial processes provided inconsistent octane ratings that varied from batch to batch, reducing both engine performance and mechanical reliability. By late 1944, German fighters received fuel allocations of 30 to 50 gallons per sortie when fuel was available at all, severely limiting operational tempo. P-47S routinely carried 370 gallons internally, plus additional external tanks. American pilots could fly multiple daily missions without fuel constraints, while their German counterparts were grounded by shortages. German pilots understood that aggressive maneuvering consumed precious fuel needed for the return flight to base, limiting their tactical options. American pilots flew without any fuel anxiety whatsoever, enabling the aggressive tactics that German pilots simply couldn't match without running their tanks dry. The P-47 Thunderbolt represented American industrial philosophy made tangible in aluminum and steel. The concept was overwhelming quantity of sufficient quality rather than limited quantity of theoretical perfection. Where German engineers pursued technical perfection in strictly limited quantities, constrained by resources and manufacturing capacity, Americans pursued adequate performance in virtually unlimited quantities, leveraging industrial might to overcome any deficiency through sheer numbers. Kartvelli's design philosophy prioritized ease of manufacture and production speed over theoretical optimization. The P-47 was actually easier to manufacture than supposedly simpler German fighters despite its greater size and complexity, because every aspect had been designed with mass production in mind. Standardization and assembly line production techniques meant faster production rates at lower unit costs. This philosophical approach extended throughout the entire supply chain supporting air operations. The identical 50 caliber ammunition fired by P-47 fighters was also used by heavy bombers for defensive armament, by ground vehicles for anti-aircraft protection, and by naval vessels for deck guns. This logistical simplification enabled economies of scale that would have been impossible with the diverse range of ammunition calibers used by German forces. German attempts to match American firepower proved futile in practice. The Focke-Wulf 190A8 variant, introduced in February 1944, could theoretically carry additional cannon in underwing pods to increase firepower. But the added weight and aerodynamic drag severely degraded flight performance, making the heavily armed aircraft helpless against lighter escort fighters. The Sturmbucker variant, specifically optimized for destroying heavy bombers with extensive armor protection and 30mm cannon, was completely helpless when intercepted by American escort fighters. The fundamental problem facing Germany was industrial capacity spread too thin. The nation simply could not simultaneously fight a multi-front war spanning from France to Russia while matching American and British production levels. Every attempt to do so only accelerated the exhaustion of limited resources and manufacturing capacity. Beyond physical destruction of aircraft and ground targets, P-47s achieved a psychological victory over German forces. The distinctive whistle produced by diving Thunderbolts became recognized as a terror weapon that affected morale as much as actual bombs and bullets. German soldiers on the ground developed persistent anxiety about P-47 attacks, instinctively diving for cover at any aircraft sound, even when no actual attack was imminent. American pilots understood and exploited their psychological advantage ruthlessly. They flew with confidence born from unlimited resources and material abundance. German pilots flew with the desperation that comes from scarcity and inevitable defeat. This fundamental difference in mental state affected tactical decisions at every level, with German pilots increasingly avoiding combat whenever possible rather than seeking engagement. The P-47 Thunderbolt achieved an overall kill ratio of 4.6 to 1 against all opponents across more than 746,000 combat sorties flown, while 3,499 P-47s were lost to all causes, including accidents, mechanical failures, and anti-aircraft fire. This represented a loss rate of less than 0.5% per sortie, remarkably low for intensive combat operations. German fighter units were suffering 50% monthly casualties by late 1944, unsustainable rates that guaranteed defeat regardless of technical quality. The 56th Fighter Group, flying exclusively P-47 Thunderbolts throughout the entire war without transitioning to other aircraft types, became the highest-scoring American fighter group in the European theatre with 674 confirmed aerial victories. This convincingly demonstrated that supposed P-47 limitations in maneuverability and climb rate could be overcome through superior firepower, exceptional durability, and highly trained pilots who understood how to exploit their aircraft's strengths while minimizing its weaknesses. The P-47's 850 caliber machine guns represented far more than mere firepower in isolation. They embodied the triumph of American industrial philosophy over traditional European military thinking. Each individual gun required precision manufacturing using complex machine tools and intricate supply chains stretching across the continent. The simple fact that America could mount 8 weapons per fighter aircraft with sufficient ammunition to sustain prolonged combat demonstrated industrial supremacy that transcended purely military calculations and entered the realm of economic warfare. Military historians examining the European air war recognize P-47 firepower as one of the decisive factors in achieving complete air superiority over Nazi-occupied Europe. The ability to deliver overwhelming firepower at extended ranges into German airspace broke the Luftwaffe's defensive capability irreparably. Once air superiority was firmly established, Allied victory in Europe became mathematically inevitable regardless of temporary setbacks or tactical defeats. The P-47's lasting influence extended well beyond the conclusion of World War II. It established fundamental principles that continue dominating modern air combat doctrine to the present day. When West Germany rebuilt its air force during the 1950s under NATO auspices, it adopted American equipment, American tactics, and American doctrine wholesale. German pilots trained on American-built aircraft, fired American-manufactured ammunition, and absorbed American military philosophy completely. The former student had become the permanent pupil learning from the victorious master. While cold statistics and production figures tell the strategic story, individual accounts from pilots provide the essential human dimension that brings the conflict to life. Colonel Robert S. Johnson of the 56th Fighter Group survived an absolutely devastating attack on June 26, 1943, that left his P-47 with more than 200 bullet and cannon shell holes perforating the airframe. The rugged aircraft absorbed catastrophic damage that would have completely destroyed any German fighter, managing to fly home across the English Channel with flight controls damaged and the canopy shattered, leaving Johnson exposed to the freezing slipstream. Colonel Hubert Zemke, commanding the 56th Fighter Group throughout most of its combat operations, personally developed innovative tactics specifically designed to maximize the P-47's inherent advantages while minimizing its weaknesses. His famous Zemke fan formation spread squadrons across a wide front, creating overlapping fields of fire that German fighters simply couldn't penetrate without running a gauntlet of concentrated machine gun fire from multiple directions simultaneously. Under Zemke's leadership and tactical innovation, the 56th achieved remarkable success, flying exclusively the supposedly inferior Thunderbolt. German pilot Heinz Knoke, author of the memoir titled I Flew for the Führer, provided valuable perspective from the opposing side when he described facing P-47 formations as confronting seemingly solid streams of tracer fire that made approaching bomber formations through the escort screen practically impossible. His detailed memoir offers rare insights into German pilot experiences and perceptions of American firepower superiority that statistics alone cannot convey. Behind all the impressive statistics were millions of American workers producing what President Roosevelt had famously called the arsenal of democracy. At Republic Aviation's sprawling Farmingdale manufacturing plant, women comprised 40% of the total workforce by 1943, performing complex manufacturing tasks with precision that exceeded peacetime commercial standards while maintaining unprecedented production rates under wartime pressure. The Lake City ammunition plant operated continuously in shifts around the clock, with workers producing billions of individual rounds in climate-controlled facilities that maintained consistent temperature and humidity to ensure quality. Teams of quality control inspectors, predominantly women, carefully rejected any ammunition varying even slightly from rigid specifications. Their dedication and attention to detail ensured that American pilots never experienced the chronic ammunition failures and malfunctions that increasingly plagued German fighters as quality control collapsed. American workers earned decent wages under reasonable conditions, lived comfortably by wartime standards, and took genuine pride in their contribution to the war effort. German munitions production increasingly depended on forced labor working in deteriorating conditions, predictably resulting in widespread sabotage and steadily declining quality control. The entire P-47 program cost approximately $3 billion, calculated in 1940s currency values. This represented a massive financial investment in a single weapon system. Yet American industrial capacity and economic strength made this expenditure affordable while simultaneously producing thousands of other aircraft types, tens of thousands of tanks and artillery pieces, and hundreds of ships. American mass production techniques reduced unit costs continuously throughout the production run. Early P-47 variants cost more than $100,000 per aircraft. By 1945, refined manufacturing processes had reduced unit cost to $83,000, despite significantly increased capability in later models. German fighter costs increased steadily throughout the war as production dispersal necessitated by bombing and chronic material shortages reduced overall manufacturing efficiency. Post-war analysis conducted by both American and British investigating teams revealed the enormous gulf separating American and German production methodologies. American factories employed specialized precision machine tools, assembly line production techniques, and statistical quality control methods. German production retained traditional craft methods fundamentally unsuitable for true mass production at the scales required by total war. The Browning M2 machine gun's basic design inherently facilitated mass production through its use of simple, robust components that could be manufactured by semi-skilled workers using automated machinery with minimal training. German weapons typically required skilled craftsmen employing traditional manufacturing methods that couldn't scale effectively. This fundamental difference in manufacturing philosophy meant that America could expand production capacity exponentially through construction of new facilities and training of new workers, while Germany faced hard limits imposed by shortages of skilled craftsmen who couldn't be replaced or rapidly trained. The P-47's complement of 8 synchronized machine guns represented a synthesis of multiple distinct American advantages working in concert. Industrial capacity provided the essential foundation, delivering the basic ability to produce fighters, weapons, and ammunition in vast quantities. Technological innovation enabled combat effectiveness through advanced systems like exhaust-driven turbo supercharging, mechanically reliable engines, and precision manufacturing. Logistical excellence ensured that materials and supplies reached the units that needed them when they needed them. Superior training guaranteed that pilots possessed the skills necessary to fully exploit the advantages provided by their equipment. No single element in isolation was necessarily decisive or war-winning. Their combination, however, proved completely overwhelming to opponents lacking equivalent strengths across all dimensions simultaneously. Germany undeniably possessed numerous excellent pilots with exceptional individual skill, genuine technological innovation in areas like jet propulsion, and sophisticated tactical doctrine developed through years of combat experience. But without the industrial foundation necessary to support these advantages with adequate numbers and supplies, they proved tragically insufficient. The Luftwaffe was ultimately defeated not by superior Allied tactics or better individual pilots, but by overwhelming material superiority symbolized perfectly by 8 machine guns firing continuously until their ammunition was exhausted. German pilots facing formations of P-47 Thunderbolts learned harsh lessons about the true nature of modern industrialized warfare. Their Focke-Wulf 190s, which were genuinely excellent fighter aircraft by any traditional standard of measurement, were simply overwhelmed by concentrated American firepower delivered through industrial mass production. 8 synchronized 50-caliber machine guns supplied with effectively unlimited ammunition represented entirely new paradigms in aerial warfare that rendered older concepts obsolete. The transformation of German pilot attitudes from initial confidence through shock and disbelief to final bitter acceptance mirrored Germany's larger World War II experience across all theatres. Initial tactical superiority based on innovation, skill, and combat experience crumbled under the weight of American mass production and material abundance that German industry simply couldn't match. The P-47, initially dismissed by experienced pilots as too heavy and unwieldy for effective fighter combat, proved conclusively that industrial might could overcome traditional tactical disadvantages through overwhelming firepower and rugged durability. German pilots found themselves stunned not merely by the sight and sound of 8 guns firing simultaneously in devastating harmony, but more fundamentally by what those weapons represented on a strategic level. They faced a nation capable of producing unlimited numbers of weapons, unlimited quantities of ammunition, and unlimited replacement aircraft. The Focke-Wulf 190 might well have been the better aircraft in terms of traditional performance measurements, but those traditional measurements had become fundamentally obsolete in the face of American industrial warfare. The P-47's 850 caliber machine guns rewrote all the rules of air combat through the simple application of overwhelming industrial power to military problems. The enduring legacy persists in every modern fighter aircraft design that emphasizes raw firepower over aerodynamic finesse, in every massive expenditure of precision munitions, in every industrial approach to military challenges. All these modern concepts trace their lineage directly back to that crucial moment when German pilots first encountered 8 synchronized Browning machine guns firing in unison and realized instantly that their entire understanding of aerial combat had become obsolete overnight. The P-47 Thunderbolt didn't simply outgun the Focke-Wulf 190 in isolated engagements. It outproduced German factories, outsupplied German logistics networks, and ultimately outthought German aviation philosophy through the application of overwhelming firepower delivered by industrial democracy. The 8 guns weren't merely weapons systems. They served as messengers carrying news of American industrial might that could never be matched by any opponent. Every sustained burst of concentrated fire demonstrated production capabilities and resource abundance that the leadership in Berlin could never hope to equal. The thunderous combined roar of 8 synchronized Browning machine guns became the unmistakable sound of inevitable Allied victory, a sound that echoed continuously from the massive factories of America across the Atlantic Ocean to the contested skies over Europe, forever changing the fundamental nature of aerial warfare and establishing principles that continue shaping military aviation 8 decades later.